Good morning. Welcome to week 2 of remote learning. Just a fun fact about this video. It's the 5th time I try to make it. You are going to need your notebook today to take notes. So please, if you don't have it, pause the video and go get your notebook. The title for the notes is going to be Making Science Graphs and Interpreting Data. Which graph should I use? This is a short 3-minute video that I'm going to attach to the assignment so that you can watch it after you're done with the presentation with my video. We have different types of graphs. Pie graph, which we use to show parts of a whole. So here we have the representation of students we have in school. We have seniors, juniors, freshmen, and sophomores, and what percent they contribute to our population. We have bar graphs. Bar graphs are useful to show comparison. So if you want to compare the performance, the attendance rate of seniors, juniors, freshmen, and sophomores, you can use the bar graph. Line graphs, which are the most that we're going to be using in science class. They show trends in data. So when we do labs, most of the time you're going to record your data and then you're going to plot a line graph so that you can see the behavior of the different samples. When we plot variables in science, we have two variables. We have the independent variable, which is a variable that is controlled by the experimenter, meaning you, such as time, date, depth, and temperature. This variable is placed on the x-axis. Then we have the dependent variable, is the variable that is directly affected by the independent variable. It is the result of what happens as time, date, depth, and temperature are changed. This is placed on the y-axis. Graphs have a lot of parts, so when you do a graph, you need to make sure that you have the title, the y-axis, and label with the units, the x-axis, which is the independent variable, label with units, and then you know what every part of it represents. So here we have, right here we have the different data points that we're plotting. This point right here where the arrow is pointing is where the x and the y-axis meet, so that's the origin. The lines, not all graphs have this. You can choose when you do it in Excel not to include the grid if you would like the background to be clear and no distractions. But you need to really make sure that you always label your graph. That's going to make your life easier when you're going to be answering questions about this graph, especially the units. You're going to lose points if you don't include your units. Okay, most scientific graphs are made as line graphs. There may be times where we use other graphs, but it's very rare that we use different graphs that are not line graphs. So when you interpret a line graph, you're going to say the behavior. Is it directly proportional, meaning that when the x-axis increases, the y-axis increases at the same time. So if the independent variable increases, the dependent variable will increase at the same time. That's why it's going up. Then we have inversely proportional, that when the independent variable increases, then the dependent variable decreases and vice versa. Okay, when we have graphs, sometimes you're going to be asked to make a prediction. So you can either extrapolate or interpolate. So if you extend the graph along the same slope, so right here, you see this line graph. If you want to make a prediction based on the behavior, it's increasing, right? It's directly proportional. So I can predict that as the time passes, my next data point will be here. This is a prediction. That means I extrapolated that point. Now, if I interpolate, I'm going to predict the data. So I know this data point and this data point. So I can predict between those two measure points, I can predict this data point. If you have any questions or concerns about this specific part of predicting data on a graph, please make sure you send me a message with your question. Now, we have a strategy known as I to the second power, which means identify and interpret a graph. Take a moment to read this paragraph. So step 1 in this strategy is identify what you see in this graph. Step 2 is interpret each of those observations by deciding what they mean. So pause the video and go over this. Step 1, you do what I see. So you put points that will remind you of what were your observations, so that then in your next step you can say what those observations meant. So what does it mean? Step 3 is write a caption for the graph of the figure. Start with a topic center that describes what you're seeing in that graph, and then you're going to join what I see with what it means in a paragraph. Okay, so look at this graph. Students enrolled in physical science and chemistry at North High School versus the years. So in your x-axis, you have years, which we said is the independent variable. And then you have number of students, dependent variable. Sorry for the handwriting. What can you say by looking at this graph? What trends do you notice, and why do you think this happened? Step 1, start with a topic center. What does the graph show? Step 2, use your evidence. What I see, make a claim, what it means. Provide a reasoning in the change of the trend in the graph. And why do you think the number of students changed over the years? Pause the video to do this. After you're done with this, you're going to submit your notes to Canvas, and you're going to go ahead and go to the August 24th DOL attendance, where you'll practice some more of this. I hope you understood the lesson. As always, if you have any questions, please email me or send me a message in Canvas so I can help you. We will be available today during office hours as needed. So let me know if you need anything from me. Enjoy your afternoon, guys. Bye-bye.